Well, if you're online, I just want to say welcome. This is Linda Sternbach. We are hosting the first Field Trip Friday Zoom meeting, and we hope to make this a regularly scheduled thing, maybe the next. And I want to introduce Richard Howe. Richard, you want to say hello to the audience?
Hello, everyone. Thank you for joining us.
Yeah, so Richard, how long have you've been doing this field trip for 20 years, you told me?
Well, somewhere, my memory fades as I get older, but probably between 15 to 20 years.
Wow. So
in some form or fashion or variation of it.
Okay, so what do you think, Diana? Should we just kick it off officially now?
Yep, let's go.
Okay, let's go. So, wow, we are live. We are starting out. So this is the Field Trip Friday Zoom meeting. We have Richard Howe. He's our special guest. He's the field trip leader of this. We're going to be watching some video that I took in May of 2009, and me and Charles were on the HGS surface faults field trip led by Richard Howe and Dr. Carl Norman. We shot some really interesting video, and I thought, well, maybe people just want to take a break today. Well, Richard's going to help narrate it, and believe me, I really enjoyed it. So it was very memorable to me. So I think you guys are going to like it. We're up to 61 participants now. So I'm kicking it off. We're pleased to have Richard over. So Richard has been active in the HGS for many years, and he is considered an expert with Carl Norman in the surface faults of Houston. Richard is a principal geologist at Terra Cognita Houston, and he's formerly a vice president at Terrain Solutions. And he's been active in variations of this trip. He's been active in applications of geology over 44 years. He's been leading this trip and variations of this trip in Houston for 20 years. Richard graduated from Lamar University and also from Texas A&M, and he's been active in areas of Texas, New Mexico, and Colorado. So his degrees are in general geology and petroleum geology, and he can speak more to that. But we came up with this idea thinking that maybe people would like a free HGS webinar on Fridays. We got some ideas for some future meetings, like I mentioned. And if we go to the next one, we're going to see some videos that were taken during a 9-hour field trip, an all-day field trip. So this is not a this is not a class. This is like highlights. This is like, as Cheryl said, snippets, teasers, as we like to call them at HGS. So we have kind of culled some of the more dramatic video, and we think this whole program will probably be a half an hour or maybe 45 minutes, and there will be time for questions at the end. Diana Fu is going to be looking for people who are raising their hand on Zoom, and she'll be activating your microphone after we get through. Let's get through at least a half an hour. We're going to definitely show these two videos, the damaged houses in Spring Branch, and part 2, the Long Point Fault parking lot. I don't know if we'll get to the Addicks Dam. You may have to turn up your personal audio for the movies, especially the first one. The audio is you can hear it. It's a little soft, but as we go on to some of the later stuff, the audio does improve. So this is personal video. I apologize for the audio, but if you cannot hear, I would just turn your personal audio up, especially for the first one. Richard and Carl were going to offer this field trip several times, and then I feel that people missed an opportunity because I took this trip in May of 2019. They were going to offer this trip in the GCAGS GeoGulf in September, and that was canceled. The field trip was canceled. However, the conference went off great. But they also were going to offer it at the APG ACE, and that was going to happen just a week ago. And of course, that has been postponed, and all the field trips were canceled. So, again, this is an opportunity for you to see what you might want to see in a future field trip. And I also want to thank my co-hosts Rosemary Latiker and Diana Fu, and they are HGS's resident Zoom meeting experts. So we're going to start off by looking at a surface fault map in Houston. Let me pull this down, and we're going to pull this up. So Richard, now this is this map is from the USGS, and I want Richard to comment on it because we're going to look at video that's in Spring Branch first, but Richard has some comments on this map. Go.
Okay, yes, this map is a map that was developed by the USGS as part of a contract for the Harris-Galveston Subsidence District. And basically they took LIDAR and previously published maps and merged them together. And one of the things I want to emphasize about looking at published maps, there's a lot of danger in relying on published maps of faulting in the Houston area. And in this case, some of their faults on the map have been misnamed, they're mislocated, or they have faults that are not faults, and they have and there's many faults that are missing. So I like to emphasize to people, when you look at a published map, be aware that there's not any real published map that's out there that's for certain. In our industry, we tend to have a problem where people say, oh, well, I saw this map, and so we're developing over here, and we shouldn't have had a problem because the map showed there was no fault, yet there was a fault going right through the middle of their subdivision, which has caused them a lot of problems. So on this map, just as an example, if you look over to the left, and where is your cursor? There
okay, here I'm putting it. You see if you can move the cursor.
Okay. Here on the Attic South Fault, I have mapped this fault out in the field, and for instance, it dies out right about in here. It doesn't cross out of the Barker Reservoir, nor does it cross I-10. So that's just some of the things, the dangers of relying on these published maps. And that's all I'm going to say at this point, just kind of a general point of information here.
Okay, so if anybody in the audience wants this map, certainly email me. I'll send it to you. I got it from a USGS publication. I was looking for the field trip from the May, and I couldn't put my hands on my field trip guidebook fast enough for this meeting, so we're using this as a general map. So now we're going to talk about Spring Branch. Let's bring up the movie, and now, this is it. So we're going to play this movie, and we're using computer audio, and what you're going to see is you are going to be like you're with the field trip itself. We are going to be in Spring Branch. The blue line is the fault axis. Okay, so Richard, this is the first expression of the Long Point Fault.
Well, yes, this is probably getting down towards the lower end of the ramp of the scarp face. Yeah.
Okay, rolling again.
The actual top of the scarp would be probably, and they've redone the driveway, but you can see in the street. Where is your cursor again?
Okay, hold on, I'm moving the participant level. Okay, cursor, got it. Do you want me to back up?
Yeah, just back up a little bit.
Okay. Okay.
All right. Right here is actually the trace of the fault. That is, the zone of maximum shear displacement is here where this fault really breaks over, and it's right about here. And it's coming through the house and the yard here. And as you start getting down here and realize this has all been poured sidewalks, the reality is that you're coming off the fault, top of the fault, into the deformation zone across the face of the fault of the scarp, and then you're coming in out of the deformation zone, and somewhere out here you're out of the fault zone.
Okay.
You want to go ahead?
Yep, we're rolling again. So let's just let this go. So, Richard, do you want to comment on your gear that you wear in the field?
Yes, this is my safari gear. Whether I'm working in the backyard or out working in the field or leading a field trip, I'm challenged as far as pigmentation. So consequently, I wear long sleeve shirts, long sleeve pants, and broad brimmed hats, and a handkerchief over my neck and ears, and tremendous amounts of sunscreen. So this is what I wear in the field. And for anybody that works in the field, I recommend this type of guard. To the right of me is Matt Cowan, who's a field geologist also, and you can see he's appropriately dressed for being out in the field these days with concerns about UV.
So that amount of thickness, thickening varies. So you can see you got periods where there's movement, periods where
Okay, don't worry, folks. The audio gets better.
respect to the upfield side.
We're gonna move now after this to Carl Norman, and he's gonna tell a little story about houses.
So if you own a house like this and you've got the money to spend, you can continue to live in it. But it's not a comfortable house to live in when the floors are not on the same level downstairs.
Inside the
Yeah.
step.
Right. Or you were lucky enough to get a convince a foundation company.
So, how's the audio for people? Is I know this is soft. Is there anything I can do to improve the audio?
Linda, we have a request that if you can go full screen with the video, is that an option for
Yeah,
you?
yes, it is. I have a little trouble. I'm gonna stretch it because sometimes I need to get to the controls to stop it, and when I go full screen, I don't know. Sometimes weird things can happen. So I'm just gonna start it again. Let's listen to this story because Carl Norman's gonna talk about what it's.
Would have been playing.
They're gonna, so Dr. Norbert, are you gonna visit with these people if they come over and want an explanation why we're staring at their house?
No, but there was a lady from Colombia that owned this house for several years, 10, 12 years.
She invited us in her house
Yeah.
to look at it.
Yeah, she invited us in. Oh, we don't, no, we got too many people. No, that's okay, come on, come on.
They had
She wanted us to see your
concrete was
backyard.
like this, and they built a step so you could step up.
Yeah, you had to walk up steps from the bedroom and up into the dining room. Okay, to do that, again, because this is a steeply dipping fault, it's a steep scarp, and when he would drive into the garage, the front wheels are up here, and when those wheels started dropping down when he got in the garage, he would be high centered, scrape the bottom of his car. In other words, the car's doing this, trying to get rid of this. So what he did was to end at the end of his driveway, just outside the garage, you put dirt where you see concrete and stuff and bricks now. And he built a little
retaining wall.
no, carport.
Yeah.
A carport. He built a carport, yeah. And so, because he couldn't drive into his garage anymore, so he made that into a playroom for kids and stuff. And now he's removed the carport. And you see, he's probably got about 3 feet from the level of the driveway to where the
If we can just interject right here, let me interject that for everybody. Glenda, can you kind of go back where it scans on the...
You want to look at the house again?
Yeah, back a little bit there.
Okay. Oops. Oops, there.
Basically, the garage, you can't, I mean, the driveway, you can't see the driveway because it's over to the left behind the cars and there's a little retaining wall. But the, let's see, where's your cursor again?
Oops. There we are.
Okay. So the driveway is over here and down below this, but that driveway used to be level with the floor of the garage when this house was built in the mid-50s, so around 56 or so. And in that period of time, the driveway has dropped that much. So, in just a few minutes, we'll be looking at a house just across the street. Now, the fault is right here. You can see the scarp of the fault as you're going into the deformation zone that's rolling into the fault here, and it clips the corner of the house here. And we'll see the opposite effect where the driveway is 2 to 3 feet above the garage floor on the opposite side of the street. But go ahead and you resume if you will, please.
Wait just 1 second. We have a question about whether the fault is still growing.
Yes, the fault up through the early 90s, we were recording the fault with average movement rates at times of well over an inch of vertical displacement per year. Since then, it's pretty much slowed, yet we're seeing some indications that it could still have some movement in sections. Now, this fault is on the order of 10 miles long. It's not a continuous fault like it's been misinterpreted over the years past. It does have offset segments along it, and the fault is, so it doesn't move at the same rate along its entirety of its length. And so we have some indications that there may be elements of movement because where you've had new street surfaces poured, you're now seeing reemergence of cracks in the pavement and
Okay.
is not moving fast. And this illustrates that the faults are not predictable, that they speed up, they slow down, they can go dormant for years, and then all of a sudden they start moving. They also respond to distant earthquake pulses that can generate sudden movement along the fault plane. So anyway, yeah.
All right. Well, it's okay.
But you can see how the entire house is rotated and snapped diagonally.
Did you point out the manhole covers over here?
I did some on this end. You might want to tell me about
okay.
Now, Letta, you might want to go back a little bit before Carl starts talking about the manhole covers.
Okay. All right. But to what, the house or what?
Yes, back to the house.
Manhole covers over here.
Okay.
Now, this house is on Westview, and it's between Moorhead Street and Bunker Hill. And it's located right across the street from the house where we saw the garage was well above the driveway. Well, here, this house is across the street where you see where the fault is crossing into the house. The house is rotated, the entire house is rotated, and then if we had a view of the side of the house, which I don't think we have in the video, you can see that where it goes diagonally through the house, it snaps the house in half. And here, if you look at the cars, you can see how they're kind of leaning down. Well, that driveway is like 2 to 3 feet above the floor of the garage.
Okay. Well, let's move. I know that coming up is a very dramatic shot of the street stuff. Let's go. He's talking about the city can shut down your house. Let's see about this video here.
If you're designing something, design it accommodate. You can't stop it from happening. You're going to fall 10 miles long and it's dropping half an inch or an inch a year. There's no way you can stop it.
You know what they did? You know what the design said?
It's not pushing and pulling like that. There is a very high wind, but it's not enough. It's not enough to start single story structures. But when you have a fault underneath the house, you're shifting the load of that roof towards the back and corner of this house. So if these members inside want you to
Yeah, I understand this is kind of challenged on the audio side. Let's move up a little bit to get to the next segment. Let's see. Okay, this part is kind of cool.
you walk into this house.
This is about, he's like people's experience living in the house.
The other thing is, people that were living in houses like this for a few years, it's like living in, what do they call those houses at the State Fair? Gravity houses. You walk into this house and the floors are tilting. That's what it's like. And you're trying to adjust your brain to this, you know. It drives you crazy. so they can only stand to be there so long. So most of them move out and rent it to somebody else. They can rent it for a low price until they can afford to, say, straighten it up. But like I say, I have said, there are homes that are sitting around here in Houston, like this, are sitting on flats that have been there for 50, 60 years. And people keep paying the cost because they like the neighborhood and the neighbors, and they don't want to move out. Just
Oh, okay. So, great point by Carl Norman that people put up with living in a house where a fault crosses under there, and so I guess in your consulting business, Richard, you and Carl together, you have counseled a lot of people who have had faults run through their house, I expect.
I work with real estate agents who are concerned about faulting impacting particular homes, and like where Linda has this stop, this is nearby on just south of Westview is a couple of vacant lots that had two previous homes on them that had to be destroyed because they were damaged beyond repair and structural integrity. And you can see the scarp, the elevation rise, the abrupt elevation rise across the lots. And the location of the fault here, in combination with city required setback limits, precludes any future construction on this lot. However, as we showed it, what will not be seen in this video, these videos today, but we did show on the field trip, people are coming in on these lots that were where the property was raised, the buildings were raised. They're coming in and building new on up. You know what, the acreage in this part of town is really expensive, and they're building right across the fault again. And when we inquire why, they say, oh well, the engineer and or architect, you know, they designed it, put in lots of piers to prevent damage by the fault if it should move. We tell them, well, that's a false narrative, because there's nothing that you can do to preserve a foundation over an active fault.
Well, let's walk with the crew here. Going to go see some pretty dramatic street footage. So here's there we are.
or it just dropped off.
But why? How do you know?
I don't.
Yeah, you do. There's your direction of movement. So you have these complexities of movement on these faults. So some type of engineered structure, a linear structure crossing the fault, is just not breaking and pulling apart. You got to take in these extra components, directions of movement. The engineers need to know this information for their design work. So in this case, it goes from here to here. That's the direction of the movement. And it's dip slip. So as Carl said earlier, we have found no evidence of strike slip components to these faults.
Now somebody might come along and think that this is strike slip. Do we see the fault? But you got to remember, the fault is entirely independent of these roads. It was here tens of thousands of years before the roads. And this side to the southeast is pulling away. So like Richard pointed out with his toes here, this point here was with this one. So it's moved over here and down. It's not strike slip. It's due to it appears to be because of the angle the fault is making across the pavement. If the fault went across this way, you wouldn't have that offset, would you? Because your direction of movement then would be directly down here. Instead, it's this way. So it's picking up this horizontal component that makes it look like a strike slip.
Yeah, that gap is your horizontal component.
So any comments, Richard?
No, it's just that the angle of intersection of a fault with a linear structure, like in this case a street, can give you the illusion that there's a strike slip component that it'll give an offset that if you're not thinking in 3-dimension, you'll say, oh, well, this thing is sliding this way, and so this must be a strike slip fault when it's not.
Okay. And boy, you can see it in the concrete there. Whew.
Linda, there's several questions that are coming through on the chat. I don't know if you guys want to take the time to answer those now, or if you want to hold those.
That part of the house is falling off.
Let's just go a little further, and when this segment ends, we'll take a question.
Rebuilt the house like that, and they saved the house. Now it looks like they're still they're in the deformation zone, so they're getting a little bit of movement, but they're not in a lot of movement.
All right, let me kind of explain what's going on here.
Okay.
This house, the original foundation of this house, there's the front of the foundation, here's the side of the foundation, and it came out to a corner somewhere right about where the arrow is, if everyone can see the cursor arrow.
We can see it.
And that was the original corner of the house. Well, the fault had dropped away so much from under the house that whole slab had broken away from the house, and this part of the house had been sagging. So the way they solved it, they came in here and they notched out the slab and then reframed the house to get out of that zone of maximum movement where they weren't getting any, where the surface was dropping away beneath the slab. But even so, you can see that they're still extending a bit into the deformation zone. Fortunately, part of the deformation zone that has a small amount of movement, but you can see the space between the siding and the here, because it's still been a little bit of drop. You still get a little drop in this foundation. The fault itself, you can see over here to the section change where the scarp is. It's going like this, and it's coming through right through the corner of the house, and it's going on to the proceeding to the left. And this house is on Panola Way at Confederate Street.
All right, let's pan around here a little bit.
Cut it back, we can see it better.
So there you go. That's a pretty significant fault there running through these people's house. I guess it kind of. Oh, okay, you're making a mark here. It kind of clips their front porch, huh?
Right, or the front of the corner, the original front corner of the house. Now, one thing is I'd like to throw in, the long point fault is our second biggest fault in terms of vertical displacement at the surface. The biggest is the Hockley fault, and this is our second biggest fault, and the maximum displacement we've seen across the fault as far as the vertical displacement is about on the order of 3 feet.
Okay, I guess I don't know what you have. Somebody's drawn on here, and I gotta clear all the drawings. Okay, I'm learning here. Okay, here we go. Oops, come on. Forward
We don't
video.
understand if this house is still standing. I call this the teacup house because it's shaped like a teacup.
They're filling in cracks in their
Cross section of a teacup. Look at those window frames.
Okay, this is fun. This is probably one of the more damaged houses. This is the teacup house.
Right. Well, that's just my term that when you for it, because when they have the shrubs cleared away, you can see the exact ground deformation across the front of the house where it bends down into the fault zone, into the sag along the fault, and back up, and it kind of gives kind of a concave upwards alignment in the brick lines and the eaves and so forth. Now you can see in this house here, where is your cursor again?
Okay, yeah. See what they've done to the door frame to try to keep the door so you could open it.
Right. You can see how they've look at the window casements and how they've been distorted and they're out of plumb. Same thing with the door, and they've had to cut a door to fit. And if you can zoom back out a little bit on this, if you can go back to where just before.
Okay, all right.
But you can see all the damage in the brick.
Look at those window frames.
Okay. All right. Well, anyway, right there, you can see a lot of separation in the brick. You can see where brick is popped off because of the stress.
Here's a
the
fun
wall.
exercise. Try to
And,
look up the value on all these houses.
yeah, right
with
there is good.
HCAD.
And so anyway, and while we were there, the couple that owned the fault came out, and they were just with tears in their eyes, and they'd spent a lot of money to people that told them they could level the foundation only to take their money and run, and they were elderly and could not afford to get out. So that's the tragedy of living in these homes. At some point, and we're not clear why they're still allowed to live in this home, but at some point when the city deems this house is structurally too unsound to live in, they'll have to have it torn down.
Okay. Well, we're at the end of this video. I really want people to see the second video, but let's take a question. Diana, you want to have someone ask a question?
Okay, there are several questions in the chat. I haven't seen any hands raised in the participant list, but I can just read a couple of the questions.
This way.
So,
Where does it go?
what are the chances of sinkhole in the future?
Well, sinkholes, it depends on what type of
You'll see they
sinkhole you're
have
talking
value.
about. If it's a sinkhole associated with infrastructure like washouts and large diameter water lines and water mains, sewer lines and water lanes and storm sewers, that's out of the province of geologists, because that's a man-induced effect. But as far as natural sinkholes, we don't have any sinkholes associated with faults unless the faults have caused damage to infrastructure, which has ended up with soil piping and soil being washed out. Sinkholes in general are typically a phenomenon here on the Gulf Coast that is associated with salt domes. On the top of salt domes where you've had dissolution of salt and or caprock depth. And as those solution cavities get big enough and the span of cavity enlarges to a point that it can't support the overburden, then you'll have a collapsed structure that occurs, and it'll, and using a wonderful word, it'll stoke its way to the surface. I mean, it'll be just a cascading effect of collapsed ceiling after collapsed ceiling, and then it'll manifest like a bubble floating up through the ground, and it'll manifest itself at the surface of the sinkhole. But sinkholes typically are associated with salt domes.
Okay. Well, let's play this video. We're going to see the Long Point Fault in a parking lot, and for all the mappers out there, you'll get to see the rather in echelon features of the fault, how disconnected it is because it's in the pavement. So here's
I'm going to let you guys tell me where to go from here. But what you're going to see here, because this parking lot is fairly new, but I think you're just standing here and looking at the elevation of the ground. You see that it gets kind of higher when you get over to the other side of the
Can you
lot?
stop it right here real quick? I just want to say this is an exercise that we run on our field trips, where we go out here to the parking lot of the Houston Community College there at the intersection of I-10 and Sam Houston Parkway West, and where you can see the fault crossing the park. This is an exercise where we let the field participants trace out the fault themselves to look at how the discontinuity of the fault and how erratic and variable it is.
Okay.
That it's not a long, arcuate, straight line.
You see
Okay,
below
sorry.
where we are, so it's going to be going through here somewhere, huh? And what we're going to do is look at the asphalt surface. This is not really thick, heavy asphalt. It's very weak material, so it pulls apart and forms cracks. So it's a good place to see the details of what a fault looks like where it's coming to the surface. And you have to remember that if you're called out to map something, that a lot of times I can see it here, but I can see it 20 feet over there, but not in between. That it can be doing a lot of things over a distance of 20 feet. And you're going to see some of that as we go along. So I'll get you started here. Follow this.
Oh, I really like this. So, look at this. It's almost like you're looking at a horizon slice.
It's not going on a straight line. It has offsets to that. So go ahead sometimes in the field, the distance between that one and this offset may be as much as a mile. It may only be a few hundred feet, or like here, only a few feet.
Is that one of your marks there?
Nope. That's some surveyors that put that in.
There you go. So there's the crack in the concrete there shows the fault pretty well.
Right, and as we proceed, you'll be able to, it'll develop a little bit better where you can see the little vertical offset across
and so it looks like we've got a signal.
Now it's going back.
Yeah, right. So here we are. We're coming back on.
Here, let me clear the sanitation off here. I don't know who's got doing. Okay. Oops, I have to go start it.
Just getting back on the track. Yeah. Just signal.
You say we're on the right track.
Yeah.
What about this one over here, Carl?
Yeah.
Here you see some vertical displacement across it. It's just changing the parking lot.
That's pretty cool. Look at that. And so what Carl was saying is that there's evidence that the fault just gaps and there isn't any displacement, and then it picks up with this much. There's a couple inches of displacement here. So it's really a fault swarm, right, Richard?
Well, yeah, I guess you... Basically, these faults really are not continuous, as people used to think they were. They're comprised of segments that can overlap, that can have en echelon relationships, staggered offset. So there's a whole lot of geometric forms, relations that these segments can have with each other. And here, where you're seeing the vertical elevation here, keep in mind that the scarp has been bladed in years past has been bladed away, and when they probably put this asphalt parking lot in. And now what you're seeing here is just more recent movement along the fault.
Okay.
But that's not the real scarp of the fault. That's the mass, and this is the eruption of the fault.
That slope, and it gave you the illusion of a reverse fault, which shows you cannot look at these faults in two dimensions, because that's not going to tell you what the true orientation of the fault is. You've got to be able to see them in three dimensions.
Where was that pit that you're talking about?
Right on the other side of the Beltway.
Now a detention basin.
Right. If you go back through the HGS archives, you can see the article. We even we gave the specs and asked people to give us the strike and dip of the fault based on the information we gave them.
Okay, I'll look through that.
I have to go pull out your old college structural.
And that building. And you'll be able to see it if you walk through the weeds and brush and stuff there. You'll see the change in elevation of the ground where the fault is. The first time I tried to look in there, I figured it was going to be running right through that building, so I went in and asked the manager in there if I could go in and look at the floor and so forth. He said, "Yeah, okay." So I'm walking around everywhere. I got nothing sign of any fault there. That building had been there long enough. And I knew we were back to the tour down here. Shit, something should show up here. So the next thing I did was go outside of the building and started walking along the south wall. There it is. And you can trace it almost all the way down to Getzer, next into North South Street. east of us.
It parallels the railroad track, is that?
It's running between the railroad tracks, yeah. That corner. They've got fences all over the place. I don't think you can even get back around.
So how does it express itself? Does it just look like a
There's a
dip
scarp.
or something?
There's a scarp like out on the reservoir.
Okay, but there would be the ballast from the track on the one side.
Oh, you
Sharp
mean,
on the other.
if it
Is there
crosses
water
the railroad
content in there?
track?
Yeah.
Yeah, if it crosses the railroad tracks. Well, the railroad people are very careful about their tracks. If they didn't do something under where this fault is going across, they'd have big problems.
Oh, sure.
The railroad spikes would be popping out, tracks spreading. They got derailed trails.
Sure.
So they're out there knocking new ballast underneath the tracks all the time.
So the fault does go under the track?
Oh yes, it goes under the tracks. Absolutely, between here and this building.
How about the fracture?
Okay, so we have a guest here, Dr. Charles Sturback. He doesn't want to say anything, but he's going to talk a little bit because we had a short presentation about cracks that go right through I-10. Pretty scary. Watch this.
Through the asphalt in the parking lot, and we're on trend. We're about north 70, north 80 east, and we're looking at where it's going to intersect Beltway 8. And what we noticed is in the concrete on Beltway 8, we've seen clues on the way here of the continuation of the fracture point. When you get here, there's some concrete, and in between the expansion joints, you see a couple more bigger cracks in here. But the big thing to note is behind the stanchion that's holding up the roadway, that roadway has extra support. It's the only stanchion that has the extra support. And if you look above the roadway, there's pretty good expansion in the two.
So there's the crack.
Well, that's not a crack. That's a joint.
Yeah.
But you're getting expansion. You get horizontal spread in the joint, reflecting the horizontal component of the fault movement.
The two sides. So if you look at the other expansion on a couple of the other parts of the roadway, there's a real separation right above that extra support. So that's what Dr. Norman says is they're monitoring very closely because it's an extension of the Long Point fault through Beltway 8.
Okay. So
let me add here that what we're looking at is the ramp from Beltway 8 up onto I-10, and I did all the fault work for the Katy High Freeway expansion years ago, and part of the work that was done, the Toll Road Authority, they did their work across the fault, and what they did is where they have these spans crossing the fault, these spans are designed to allow for a certain life of horizontal movement. In other words, those girders are designed to allow the girders to slide horizontally without pulling off of the piling. So there is movement capability built into the design of these overpass ramps to accommodate for a certain amount of time fault movement.
So is the public safe, do you think, or does this have to be redone at some point?
Well, they monitor this, yes, so the public safety is safe. When I drive over this ramp, I don't even think about it.
Okay. Okay. Well, hey, we're at 45 minutes. We've gone through the two videos that I thought we could fit in here. I'm going to now say, hey, it's time for some more questions. Let me try to get, this is the problem, I got to get this off here. Oops.
I can read through a few questions that have come through.
Yeah, okay.
Alrighty.
So two questions, I'm going to combine them because they're related. So this goes back to the area where we were in the neighborhood. Has the city condemned any of these houses, and can the condemned lots be used for playgrounds or dog parks or other facilities with only above ground structures?
Yes, the city has condemned some of these homes over time. They've condemned actual large commercial department stores that went across where the fault went through them and damaged the structural integrity of the buildings. The problem is buildings are designed to withstand vertical compressional forces. And when you get distortion in the structure of the building where building walls start to get out of plumb and they get to a certain point, they're not designed to take on the shear stresses that come when they tilt out of vertical alignment. And so thus as the more they tilt, the more they get out of alignment, the more the structure is pulled apart horizontally, is literally pulled apart. At some point, the damage can be such that there's danger of structural failure. So there are cases where the city will go in here and do this when they deem things are dangerous enough to do so. And these areas there where you do have faults going across lots, there have been some ingenious ways, and we have a stop on our fault trip where we go and show where an architect, she went on the high, stable side of the fault on her lot. It was a narrow, expensive lot over there near Headwood Village. And she put in piers on the high, stable side of the fault and used a foundation of I-beams sitting on those piers, anchored on those piers, that cantilevered the house out over the fault zone. So the house was suspended out over the fault zone. That was a unique, ingenious way of getting a structure to utilize a adversely impacted lot, but of course that was a tremendous amount of money to build a foundation like that.
Okay.
But
Hey,
where you can't build a building like the question says, what can these zones be used for? Yes, they can be used for parks, playgrounds, green belt. You can put in detention ponds there, so so there's a lot of uses here that can be applied to these zones. So yeah, that's how you would use these areas where you have the fault deformation.
well, let's take one more question. I really wanted to keep this to 45 minutes, but let's take one more question.
Ooh, you're gonna make me pick. Let's see. Okay, there's a couple questions about insurance, and do homeowners insurance address this in any form?
Unfortunately, no.
Okay, another question, geological question.
Okay, another question. Let's see. What is the source of these faults?
Well, we have two types of faults on the Gulf Coast. Those are faults that are associated with salt domes, and then you have regional faults that are associated with the overall extensional stresses of Gulf Coast tectonics. The extensional stresses that we have as our sediments are sliding and subsiding into the Gulf Basin. And so, but they're all normal faults, which means they're all induced by extensional stresses one way or another. I mean, with the case of the salt domes, the salt is flowing up from beneath the surface, and as they rise toward the surface, they induce extensional stresses over the dome, and that can generate faults. So, what was the original question again?
What was the source of these faults?
So that's really the source of these faults, is just simply it's extensional stresses that's associated with Gulf Coast tectonics.
Yeah, and I think Carl made the point in the video that they really predate human civilization. These are not
millions of years.
Yeah, so these are not these long point faults, or this is not something that has anything to do with human beings. Been there for a long time. So,
right, and take for instance the long point fault. Seismic has shown the long point fault to extend down to around 17 to 18,000, and then it appears you can't really see anymore, and it's probably going listric. These are very old faults, and they're all faults. All normal faults in the Houston area that we've encountered all have growth on them, so they're all growth faults.
yeah, I do remember that U of H shot a seismic line along the edge of the, I think 59, and that is publicly available. It's in a publication I can send you, but I didn't think it saw the fault very well. I guess
No.
it was their equipment. They said you could see the fault, but it was pretty fuzzy to me.
Here's the deal, is that a lot of people, especially U of H, has done research over the years trying to use surface geophysics of various sorts, including ground penetrating radar, shallow seismic refraction, reflection, electromagnetic surveys, with limited results, and they're not consistent. And they always tend to run these surveys where they know the fault is. And so they're not sufficient for our use for identification and delineation of the fault and the ground deformation that accompanies it. That really has to go back to field work and the old tried and true method that's been proven since 1927, and that's the use of electric logs. Ultimately, when there's any doubt as to where the fault is or where it's going, or if it's existent or not, you have to drill expensive boreholes down to depths below 300 feet and run geophysical logs down the holes and correlate them just like you do in the oil industry.
Okay. Well, our participants are kind of getting off the call now, and we did go over the 45 minutes. So, I know we probably have questions. I would say you could email me the questions, and I'll forward you over to Richard if you want to directly correspond with him. I think it's a tremendously interesting project we have here, and I really thank Richard for coming on the call. And you got to meet Carl Norman. He wasn't available, but Carl is a professor emeritus from U of H, and he knows a lot about faults on a house-to-house basis all the way through here. He's a tremendous resource, and he's still consulting, even though he's been retired for many years. So I think we're going to end the call now. Check the HGS calendar, June 26th. We're going to do another faults. I believe it's going to be the Grand Canyon. So we're going to have a half an hour of Grand Canyon. HGS ran a Grand Canyon trip, which Charles and I were on in 2009. And you'll get to see a lot of whitewater rafting and what fun it is to go on that trip, which I guess you can still sign up for next year. And so you might want to phone in on June 26th, Friday, 11 a.m. for the next Friday Field Trips Zoom meeting. So thank you so much for attending. Thank you, Richard. Thank you, Diana. And hey, guys, have fun this weekend.
All right, same to y'all.
And,
Bye.
thanks for giving the video.
You're welcome.